Hi guys, welcome to the second section, implementing socket IPC. In this section, we will start with backpressure and reactive extensions. We then move to implementing process observable. After that, we will see server manager application, server manager, and the Unix socket server. Now, we move on to the first video of this section that deals with backpressure and reactive extensions. In this video, we're going to take a look at Lossy and lossless backpressure. We will also implement throttletime operator with filter operator. Observables are streams of data that are produced by the source observable on one end and consumed by another observer at the other end. We are not aware of situations where the observable is emitting values so fast that the consumer is not able to handle them. This could lead to significant memory or CPU usage, which we definitely want to avoid. There are two groups of operators suitable for backpressure. First group is lossy. In this group, some values are discarded and never arrive at the observers. For example, a mouse position sampled over a certain time span. We are usually interested in the current mouse position right now. We don't care about position in the past, and so this can be completely ignored. Second group is lossless. In this group, values are stacked in operators and are typically emitted in batches. We don't want to lose any data, so a typical inner implementation of a lossless operator is a buffer. We usually deal with use cases similar to the RxJS operator that is throttletime operator. This operator takes the time span as a parameter, which defines how long after emitting a value it'll ignore all subsequent emissions from the source observable. The marble diagram explains the functionality of throttletime operator. The throttletime operator is implemented in PHP, but we can implement it ourselves using just filter operator, or even better, by creating a custom operator to see how this and a similar functionality can be implemented internally. Now, we simulate a hot source observable with interval observable class, which periodically emits values and will filter out everything that arrives less than a second after the previous emission. Now let's take a look at a code example. It simulates a similar functionality as the throttletime operator. Now let's run it. As we can see, the interval observable class emits ever-increasing counter values, where most of them are ignored. However, this is not a very systematic approach. We have to keep the last timestamp in a variable, which is what we usually want to avoid with Rx. We now kill the process. Let's go back to our code. Here we can see a variable last timestamp that we are using for the last timestamp. Our callable for filter function doesn't take any arguments because it doesn't matter to us. So let's re-implement the example into a standalone throttletime operator class. This code snippet is our entire code. When implementing custom operators, we need to be aware of correctly propagating not only on next signals, but also on error and on complete. We can delegate all this responsibility by reusing already existing operators, which is in fact a recommended way of implementing new operators to Rx. This means that our operator just sets up a filter operator that takes care of everything for us. Using throttletime operator is simple with the lift method. Now we move to another code. Here, with the help of the lift method, we can use throttletime operator. Now let's run it. So this is a lossy operator. All values that don't pass the predict function to filter are lost forever. In RxJS 5, typical lossy operators are audit, audit time, throttle, throttle time, debounce, debounce time, sample, and sample time. In RxJS 4, we also have the pause operator. Lossless operators are those that don't discard any values. Values are just stacked and sent to observers in batches. In RxPHP, we can use the buffer with count operator that takes as an argument the number of items stored in the buffer before emitting them to the observers. We can also specify the number of items for the beginning of the previous buffer we want to skip. The marble diagram explains the buffer count operator very well. Now we move to another code example. In this example, we will use buffer with count operator. Here we are buffering 4 values, so when the source interval observable class emits a value every 500 milliseconds, the observer will receive a value every 2 seconds. Let's run it. As you can see, we are getting 4 values in our buffer, and the interval buffer class emits values every 500 milliseconds. That is, the observer will receive a value every 2 seconds. In this video, we have learned backpressure and reactive extensions.